Hello, welcome everyone to our monthly Julia Beginner AMA. This month we have some amazing contributors to Julia and very active in the community. Mosè Giordano and Mason Porter.
Protter.
I don't know, Protter, sorry.
No problem.
And sorry, Mosè, if I said your name slightly wrong. Yeah, do you want to start off by just like saying a couple things about yourselves, just as an introduction, and then we can go from there?
Sure. Oh yeah, go ahead.
Okay, thanks. I'm Mosè Giordano, so the pronunciations was right. And I'm a research software engineer at UCL, University College London. And I've been using Julia for like 5 years now. So I'm pretty excited to be here. Yeah.
And Mason.
Okay, so yeah, I'm Mason Protter. I'm a physics PhD student at the University of Alberta. I kind of started using Julia, I guess, in the summer of 2017. I had heard about it a bit before that and was not very interested. And then I started reading some things that kind of changed my mind and started checking it out and kind of just fell in love with the community and the language, and I've been spending a lot of time here.
That's awesome. I'm personally very excited that you two are here today to answer questions. Like, you already answer a lot of questions online, so that's super awesome. Thanks to both of you for doing that. And then the one thing I would want to say just before we like dive more into the questions is to just like to keep scoping the questions for everyone who's asking questions on the Pigeonhole link, to keep scoping the questions to beginner level. Like, if you have a more advanced question, I think you can ask it, but just don't expect to have a very detailed, like super like compiler level, let's say, like let's just like, go into the super details of whatever the question was and answer it. We want to try and keep those sessions kind of the theme of them is for beginner type questions and beginners to come and ask questions here. Of course, if you have advanced questions that you would like detailed answers for, I would say Discourse is a great place, Slack, and there's an idea of having the similar concept of beginner type questions, AMAs, to do the advanced type office hours or Q&A. We'll see if this will actually happen, but this is just an idea floating around. It might happen. But for now, yeah, just keep scoping the questions to beginner level. And with that, there's already a bunch of questions. I don't know if any of you want to pick out anything that seems reasonable for you and start answering it. I think there's. Okay, go ahead. You can go ahead and. Yeah.
No. If you have questions in mind,
I was just thinking there's the Julia 1. Since this is the first AMA after the 1.6 release, I think that would be like a cool thing to talk about. It doesn't need to be now, but I think it's a very good question.
Yeah, sure. So I don't have the release notes in front of me actually for 1.6, but it came mostly with a lot of quality of life improvements, I'd say. Like one issue that people often have, I think, when they're starting out in Julia, is that they write code with some bug in it, and then they get a stack trace that's, you know, unreadable, and so one of the big improvements is that the stack traces have colors to kind of guide your eye and show you which information is actually useful and which information might not be, and then new users, especially coming from like Python or MATLAB, or well, maybe less so MATLAB, but R, feel that the time to first plot is very burdensome, and so there's the parallel pre-compilation. So your computer will use more threads when it's pre-compiling, and that leads to some big speed ups. But I think it's even faster single-threaded as well now.
Yeah, there have been a bunch of general improvements to pre-compilation, but in particular now it's in parallel, so it's much faster. So I agree that the general theme of this release has been quality of life improvements. So I don't think that there are many huge new features in the language, but a lot of good quality of life improvements.
Which is awesome for anyone who wants to get started and doesn't want to deal with, say, time to first plot or the stack traces. This is, I think, a very big trigger for people to actually go ahead and use Julia. So that's good for that type of improvement.
Yeah, I should say there's a set of release notes on the repo.
I'll try to find them and post them on the Julia on the chat. So
yeah, it's always a nice thing to go and look through. It's like Christmas, finding all these new features. So I see there's one of the questions with 2 upvotes here is what's the best resource to learn Julia as an R user? So I'm not actually. Do you have much familiarity with R, Mosè?
Very little. So I don't really know what could be the best resources to learn Julia.
Yeah, I know a bit of R, but I don't really have much experience with the tutorials. Do you have any thoughts, Udo?
yeah, I think so. For me personally as well, like I haven't done like any like large project with R, but I've had to deal with some R code throughout the years, like just like someone else's code, for instance, or something like that. It seems to me that data frames is like one package you want to know about for sure when you're moving to Julia. So that's one thing. And then in general, there's that's one package. And then there's another package you might want to know about, which is the Arcol package. Just because I think sometimes when people move from one language to another, they're still like very used to certain things that are done in a certain other language. And like it becomes like if they want to figure it out in Julia or like it's not implemented in Julia or for any reason, they might want to be able to call whatever they used in the past immediately, or if they want, if they already had written R code in the past that they don't want to port it entirely right now, they could also use Arcol. So for instance, that's another package to just know about. And in terms of learning, I would say in general, like I don't think any of the the learning material on julialang.org/learning, I think should be accessible to people from different backgrounds in programming languages. I have seen some like blog posts and like threads around about like, oh, like if you're a Python user, these are cool things to know about Julia if you're switching. I can't recall anything about R specifically, but the julialang.org/learning should be a good place to start for anyone from any programming language in the past.
One thing I'll say also is that there in the documentation, the language documentation does have a section on major differences from other languages, and so that's always a good thing to read.
Yeah.
And online you can also probably find some other cheat sheet of comparison between R and Julia.
Mm-hmm.
I'll try to keep track on all these links we're mentioning and try to post them on the chat.
Yeah. You want to choose a question, Mosè?
Yes, let me see. So there is a question, what are the Julia packages that everyone should know besides Snoop compiler? So since the question mentions Snoop compiler, I guess this is kind of development tools that every new Julia user should know. I would say Revise, which is great if you don't want to restart the shell every time that you are developing or working on a package. So Revise basically automatically reloads the package that you're working on. And so you don't have to, again, close the repo and restart to get the package re-updated. So this is done live by the package. So Revise is definitely the mandatory package that everyone should use, especially for development. And do you have other ideas?
The only other one I can think of that I would recommend to almost anyone is benchmarktools.jl. I think if you want to understand how your code is performing, which almost everyone who's interested in Julia should, Benchmark Tools gives you some very powerful tools for understanding the performance of your code. And then beyond that, everything starts becoming very domain specific. So the question asker mentioned Snoop compiler.jl, and I don't think that's not a package I would recommend to most people. It's basically something. It's a tool that people can use to reduce the compilation time of packages they're writing, basically. So not even most package developers really look too deeply at Snoop compiler unless they're writing a very big package that's very slow to compile. But I would say, like, if we were to get into, kind of maybe slightly more specific grounds, like I'd say, like, if you're interested in doing numerical stuff, and you need things like very fast loops and vectorization and stuff like that, then I think loopvectorization.jl is one of the, like, maybe it's not like the thing that everyone should use, but it's something that everyone should be aware of that's out there, because it's a very special, very powerful package for writing extremely fast performant code. But it's important to also understand, like, what its limitations are before you start using it, stuff like that. Yeah, I don't know. So it's hard to recommend packages without a domain in mind.
There was a type inference package. I can't remember. Oh, C. C2 tool. Yeah. That's another
Cthulhu.
one. Just because, like, because, like, if you're doing type, stable type code in Julia is also another thing that everyone should be aware of and care about. So that's another package that can be helpful.
Yeah. So I think the Julia community tends to use debuggers less than a lot of other language communities, I find. And so I think, I mean, we do have debuggers, and if you like those, there's a couple that people should check out. But Cthulhu.jl is kind of like a debugger almost, except it's happening at, like, kind of compile time. It's for, like, walking, basically the tree of the code abstractly. So that's and you can find all sorts of type inference issues with it. So yeah, it's definitely a good suggestion. Let's see. What features make Julia better than other languages in certain domains? So I'd say for me, like, one of the things that really got me interested in Julia in the first place was its ability to do metaprogramming. So I kind of became interested in various Lisp languages, which have a very strong tradition of something called like writing macros, which are essentially writing programs that write other programs. So you're kind of doing your own code generation, and I think Julia does this sort of thing very well. This is an advanced feature. Don't really worry too much about it, but I think this is really one of Julia's greatest strengths as a language, because it lets people write. It lets Julia have incredibly flexible semantics, so that it can be used in many situations where if you were to use, like, for a more regular language that doesn't have these sorts of abilities, it might not be able to be kind of repurposed and used in different situations that it wasn't designed for the way Julia can. I think it's very possible to kind of embed small languages in Julia because of this metaprogramming, and I think that's a really great superpower that it has. And then, there's obviously, like, the composability and speed that everyone talks about, and those are really important too.
Yeah, and I see there are already other questions about why Julia, if I know already Python, Go, or other languages. So I think this is kind of the theme now, the questions that are coming.
Yeah.
So I started using Julia probably because of the speed, because I heard some papers, scientific papers about doing some analysis in this cool language that is also fast. So yeah, probably for many people, the first approach to Julia is because you heard that it's fast. But I don't think this is the main reason why I use it today. Yes, it is fast, but for me, it's just like a nice addition. What I found great about Julia is the composability. So it's very easy to write your own package, your domain-specific package, and find out that it works out of the box with some other packages in other domains. So it also encourages like interdisciplinary works with other people that you don't know in domains that you don't know. And this is great. I don't think that other languages, especially if you're talking about scientific computing in general, I don't think that other languages have these capabilities.
Yeah, I just echo that I'd use Julia if it was slow. So, you want to choose a question?
Okay, so there is a question about how to save precompile the Julia code for faster run for first time on another system. So this is something that package compiler should be able to do for you. It's a package which allows you to build basically the so-called system image in the Julia terminology. And yeah, for example, if you add plots.jl, which is the most common package for plotting, or also Mackie, it's another common one. If you load Julia with this using this system image, the loading will be super fast. The downside is that the size of the system image is not very small. It can be a few hundreds of megabytes. But if you're not concerned about the size, that's a very good way to reduce startup time, especially if you work in production. This can be not very convenient if you're developing packages because the system image needs to be regenerated every time that you change packages. But in production, you probably want to keep a defined set of packages for some time. So that can be a very good use for this package.
Yeah. People often use package compiler to bundle things like their plotting library and some other hefty packages. Like I think I've heard a lot of people use differential equations in their system image because it can have long startup times, stuff like that. So if there's a package that's kind of stable and is not updating super fast, because you have to regenerate the system image every time you update the package. Yeah, and then there is active work happening on kind of static small binary compilation, but that is not ready for even advanced users yet. So yeah, I think package compiler is definitely your best bet right now. So there is a question I had been meaning to get to about, so someone says, I read a lot about Julia symbolics. This looks like a big research project into symbolic algebra. What do you think about its future? So I did some work helping out with, it's mostly a project being run by Shashi Gowda and Yingbo Ma on in symbolicutils.jl, modelingtoolkit.jl, and symbolics.jl. And I think it's a really cool project. So kind of the ambition originally had been kind of to do some simplifications for differential equation models and stuff like that. And the scope is kind of widening to the point where now the intention. Okay, so I maybe just to take a step back and give the context. Julia has our ecosystem has a very strong focus on numerical scientific computing, but sometimes you want to do things symbolically. So more kind of automatically doing the sort of math that you might do on a piece of paper. And so this is something that languages like Mathematica and then Python packages like SymPy, I think MATLAB has some capabilities for this as well. They all have these symbolic algebra libraries, and they're very difficult to build. They take an incredibly large amount of work, and they tend to have much fewer users than numerical libraries. And so it's quite hard to build these things. So we're kind of trying to make that happen and trying to make an ecosystem around it. And yeah, so I think the Julia symbolics thing is on the right track. There's a lot of work to be done, but it's slowly getting there, and we welcome new contributors.
Okay, so there is a question about is multiprocessing or threading transparent in Julia? Like, can I inspect variables on other processes? Honestly, I don't know this detail. I don't know if you, Mason, know the answer.
So I know multi-threading is in Julia shared memory. So so everything is, there's just one namespace of variables. Now, for multi-processing, I might be wrong here, but my understanding is that there is a way to request a variable from. You can say, what is this variable on this process, but it's not like a shared namespace between all the processes. Like, for instance, if you want to define something on all processes, you use the everywhere macro. You would type at everywhere x equals 1 + 1 or something, and then that would define that variable everywhere. So someone is asking, is Julia Hub a good place to get started with Julia for poor students, or would installing it on whatever hardware you have make more sense? I think generally, I don't really like using kind of remote access tools. I think, like, generally, if you do have some hardware lying around, I would rather just run it locally. But this also depends on what you have lying around. Like, I think from what I understand, you can run Julia on a Raspberry Pi somewhat well, and those are very cheap. I think you can get them for like under $100 still, like the new ones, and then the older ones are cheaper. So technically the cost can be pretty low. Now, it might not be the most pleasant experience, but yeah.
It depends also on the use case. If you need to do like some heavy numerical computing, probably it's not an option. But if it's something lighter, yeah.
Yeah, I think actually the biggest constraint on something like a Raspberry Pi might be the RAM. I think last I heard, you can't actually compile Julia itself on a Raspberry Pi because it requires too much RAM. So like you can't build it from source.
Yeah, I think we actually, maybe 2 or 3 years ago, we tried to run Julia on a Raspberry Pi in one of the projects at when I was a grad student, and yeah, we couldn't compile it, but we were able to just run it on a Raspberry Pi, so that's doable. Yes.
Yeah, I'm just thinking, because I think when I last tried to do it, it was like Julia 0.7 or something like that, or 0.6, and I think this was before we had Binary Builder, and so it was Julia was trying to. this isn't too relevant, but but basically the building Julia from source is now much more streamlined and downloads certain dependencies. So maybe it's okay now.
That's true. I think you're right, actually. Yeah. Now it's same thing. When we tried it, that was before Binary Builder. So yeah, things might be different now. So it might be worth a try.
There's a question here about, would you recommend Julia to be the first programming language, or to learn it, or is it for established programmers looking for a faster language? I think, because of the nature of Julia's community, a lot of, maybe even the majority of people who are using it right now, I don't know too much about the statistics, but I'm sure a lot of people came to Julia from another language, but I don't think that's necessary. I think Julia would be a great first language to learn. And I think in particular, Julia will teach you a lot of things that are like learning Julia first can be very beneficial, because it encourages a lot of style things and teaches you to think about code in certain ways that can be very beneficial in other languages as well. Understanding how to write good Julia code can help you write good code in accelerators for Python, for instance. Like if you were to use Python, there's things like Numba and PyTorch and all these things that have a somewhat similar compilation model to Julia, and a lot of the things that you learn in Julia can be useful there. Yeah, I think Julia is a great first language to learn.
Yeah, and what I like about Julia is also that you can use it at different levels. So you can use like a high level without knowing much details. But if you want to know more, you can easily go down and learn more and more. So I think, yeah, I agree that as a first language is a great tool, because you can go as deep as you want, but you don't have to.
Yeah, I think like for me, it really I was not too interested in getting into deep low level language things, and then kind of just one step at a time started learning things, and yeah, it kind of just drew me in.
There is a question about, is Julia better than Kotlin? I don't see. I am not very familiar with Kotlin, but I don't think they're very easy to compare, because probably they target two different domains. That's my understanding of Kotlin. Because I think that smartphones use Kotlin, so it's more easy to use on small devices, and Julia definitely is not something that nowadays at least can run on a small device with not much memory. So yeah, I don't think that there is an easy comparison between the two languages. But there is also in this question a question about the job market in London. So I feel, for example, on Discourse, there is a section about jobs advertisement using Julia, and from time to time there have been some job opportunities using Julia. But in general, I would say if you like it, learn Julia, and maybe start slowly suggesting in your company for some small tasks. If you believe that it's a good option for the work that you're doing. But yeah, I don't think that there is a huge job market right now, but some opportunities definitely there are, and keep an eye on Discourse.
I think a lot of job postings kind of overestimate the strictness of the language requirement. Like they might say, like, we want a Python developer, and sometimes they actually mean they want a Python developer, but they don't always necessarily have like a very strong language requirement. But it depends a lot on the sort of job you're doing. Some programming work is very solitary and some is very team-oriented. And if you have a very integrated team, you probably want everyone using the same language generally, if they're reusing each other's code. So yeah, this is one of the downsides of a small language, but it's growing very fast, and it kind of just depends on what you can find. And yeah, I don't know anything about Kotlin, but I think I suspect if I did know anything about Kotlin, I would say neither is better than the other in general. But you know, if you have a domain, then maybe one of them is a nice choice. So LT is asking, how much faster can Julia be compared to Python's Numpy? Any best practices that you would recommend to keep codes efficient at all times? Yeah, so I mean, in the best case scenario, for Numpy, they can be just as fast. And you know, sometimes even I'm sure there are cases where it would actually be pretty difficult to write Julia code that's faster than the Numpy code because the way Python's so-called garbage collection, the way it deals with memory, is different from Julia's, and so there are trade-offs to be made there in situations where it can be faster. I think though that, and the other thing I should say is that if you're timing individual functions, like say the sum function or like average or whatever, addition, if you're timing individual functions in Numpy against Julia, you might not see much difference. You could even see a small advantage for Numpy. It depends. But what's special in Julia is that our compiler sees kind of everything from start to finish, and can do lots of optimizations that we can fuse operations together, and whereas in Python there's kind of, you know, there's the Python space that's separate, and then there's the C implemented stuff over here, and Python operates by kind of just taking inputs and sending things over there and back and forth. And so every time you do a function call, there's kind of this barrier of Python that can't be, basically certain optimizations can't cross those barriers. And so that could be a very big difference between Numpy and Julia in general. And I guess I would say that, like, just empirically, very few people find that Numpy alone is enough for them to write fast code. It's probably not a exaggeration to say there's probably around $1 billion being poured into efforts to make lots of different tools for writing faster Numpy-like code. And you know, there's some great work happening there, but I think Julia has some really big advantages because it's not tied to the specific way you write Python code.
And also related to this like language barrier between the C side of NumPy and the rest of Python, there is a problem in the Python ecosystem that if you have a custom class, you cannot easily have like a NumPy array of this custom struct because NumPy doesn't know anything about this. So if you find a few packages implementing custom class, they probably are also implementing a custom interface, some glue code to NumPy in order to be able to do like linear algebra operations using NumPy. And also this will only work with NumPy, but there are also other different implementations of NumPy-like structures in the Python ecosystem, and they won't work altogether. So this to come back to the argument of composability of different packages in Julia, which is a big strength of the language.
one thing, I kind of forgot to address the second half of the question, which was about best practices for performance. And I think this can be kind of tricky, but I think I would definitely just say, like, time everything. So, like start running benchmarks on things and break your functions up into small pieces so that you can time individual parts, and try and understand, where a lot of time is being spent, and then ask lots of questions. Go on Discourse or Zulip or Slack or whatever, and get help, because there's a lot of people that are, especially if if you say that your Python implementation is faster than your Julia implementation, then suddenly 100 people will crawl out of the woodworks and start micro optimizing all your code, and have all these suggestions for how you can get 100 times faster or whatever. But there's a lot to be learned from. There's a lot of very experienced community members who are very generous with their time sometimes in answering and helping people write faster code. So it's a great resource to take advantage of.
And a couple of concrete tips about performance. I will say learn about type stability and memory allocations. So in my experience, if you don't have some crazy code, if you reduce memory allocations and have some type stable code, it will be super fast. So learn about these two concepts.
Sorry, go ahead. No, I was just going to add a small plug on like some resource that people can go to as well, which is like there's a page in the documentation as well on how to performance tips, essentially how to make your code faster. And there's actually a JuliaCon workshop from last year that basically goes over memory allocations, how to make sure you're not over allocating, or how to profile your code or benchmark, and goes over type stability as well. So like you always want to write type stable code. You want to make sure where your memory is going, and how much are you allocating memory, and are you reusing memory, and all of that stuff. So that workshop kind of goes over that as well.
So just in case anyone doesn't know what these terms really mean, so type stability means if I give you some program and I tell you the input types to that program, that you can predict exactly what the output types are at every stage throughout the program. And this is what lets Julia's compiler write fast code. And it's this property that makes it hard to write compilers for languages like Python or R or whatever that weren't designed with this property in mind. And I think I remember myself being confused about the term memory allocations for a while, and how that was different from like so-called non-allocating code. So I just say, like, if you can't predict the shape, like how much data is in some data structure at compile time. So in a tuple, you know from the type of a tuple that how many slots, like how much data it's holding, and so that can be so-called stack allocated. So you can write code that exactly programs for how much space it's taking up, and then this can be dealt with very efficiently. Whereas a vector, like some array, does not have a definite size at compile time, and so needs to be what's called heap allocated, and then garbage collected. So this can come with some performance penalty, because you need to plan for any size of your data.
Okay, so there is a question about what aspects of Julia work differently on Windows, Mac, or Linux. I don't think that in general you should be concerned about differences between the different operating systems. You can find differences if you do some platform-specific operations like work with the file system. But yeah, no, in general, I don't think there are many notable differences. I'm usually not concerned personally.
Yeah. I think so. I've used Julia a lot on both Mac OS and Linux. I haven't used it very much on Windows, but my understanding is that Julia is pretty special in terms of open source languages, at least in terms of its Windows support. Windows can be a very hard platform to support, especially for developers who are kind of Linux centric. And I can definitely say a lot of work has gone into the Windows support. And some things are still not perfect. I think like sometimes there can be some REPL issues or something with colors and stuff. But I think I think a lot of work has gone into the Windows support, and it's quite high quality. The goal is for the user to never know what never need to know specific things about their platform. There's a question here about main differences between multiple dispatch and object orientation. So this is an easy place to get sidetracked semantically. So because one has to ask when you say object orientation, what that really means. So to a lot of people, object orientation means classes. And so a class in say Python or something is some object which is kind of like it's a type basically, and it stores data. You might have some class that stores like the real and imaginary parts of a complex number, and then it would also store functions that they call methods, and these methods can operate on the data that it's encapsulating and other data that you pass in. And then Julia's multiple dispatch. So generally classes have what's called single dispatch. They can generate different methods depending on the type of one object in the code. In Julia, we have multiple dispatch. So if you write function f of a, b, and c, you can have a different implementation of f depending on any combination of the types a, b, and c. So for there's lots of different dispatch paths that can happen. And so the single dispatch from traditional object-oriented languages is a strict subset of that. But then, like if you look at kind of how people define terms like orientation, like if you go on Wikipedia and search for object-oriented programming, the actual kind of definitions, like especially the older definitions, are very vague and involve things like encapsulation and polymorphism, a couple other things I forget. But basically, the person who created that term, object-oriented, has gone on the record saying that he did not mean things like Java or C++. Like that was not what he was talking about when he tried to invent this term. And I think Julia does satisfy a lot of what people originally meant by object-oriented, but because it's not such a popular term anymore, like a lot of people are kind of dissatisfied with modern object-oriented languages. I think the Julia community has not really tried to advertise itself as object-oriented, even though it could if it wanted to, I think.
I don't know if you wanted to add something, Mosè, about this, but before we switch gears, I just want to say there's a really great talk by Stefan Karpinski on multiple dispatch from JuliaCon 2019, where he actually, if I remember the talk correctly, he does kind of compare and contrast these concepts in the talk, if I'm not mistaken. I'll try also to find the link, or if Logan can find the link and paste it. I strongly recommend watching that video.
Yeah, so languages like C++, for instance, have something called operator overloading, and they use like basically compile time templates to do something that looks a lot like multiple dispatch in Julia, and this is a common point of confusion for people because it seems like the same thing, but it's actually rather different because the basically if you input a type that's not known, then kind of the abstract type goes in, and so the behavior of the program depends on how the type inference ran. So that might be the distinction that you were remembering, but he does talk a lot about like class-based stuff as well. Like, it's been a little while since I saw it.
He did talk about class-based stuff, but the other thing is that as I'm talking about the multiple dispatch and I'm trying to find the link, I can't multitask, so I wasn't like listening 100%. I was told the link is there in the chat already, yeah, he does touch I think I remember there was like, because like in object oriented we always like just think of like cat, dog, or like person, and like how do you extend a class from another, and I remember he talked about a similar example, and that's why it's kind of I remember that.
Yeah, I think he does the example of the dog.
Yeah.
Okay.
Okay, there is a question about how does distributed multi-machine. Wait, I lost the question. Here it is. Sorry. How does distributed multi-machine execution work, and parity with Dusk and Spark? So distributed execution, basically you spawn multiple processes. They are kind of independent, but they can talk with each other. So you have like different Julia processes running in parallel. So in general terms, if you want to make your code fast, you should avoid talking with it with all processes. So if you reduce communications, basically all processes then can go on their own, and this is called usually embarrassingly parallelism. And Julia does support this kind of parallelism with, for example, distributed package, which was already mentioned before. Parity with packages in other languages like Dusk or Spark. I think that Dusk in Julia is a kind of equivalent in the dagger.jl package. And I'm not very familiar with Spark, so I cannot comment on that.
Yeah, I think I remember there's a post somewhere on Discourse talking about comparisons between Julia's distributed stuff and Spark, but I off the top of my head I don't know what the title or anything would be, but I this has definitely been discussed before, but I think the general consensus I've heard from people who do a lot of distributed computing is that Julia's tends to be a bit better at multi-threading than like our kind of language support and tooling around multi-threading is a bit better than our support and stuff for distributed computing, and that's mostly because the distributed stuff was built first. But there is a lot of great tooling and there's built-in stuff in base for distributed computing, but then there's also there's packages like mpi.jl, which I think you could do distributed computing with that. And then there's also like as you mentioned, Dagger, and then like TKF, Takafumi has done a lot of really cool work in the Julia folds stuff. If you like doing closure style transducers, then there's some really cool ways that you can write kind of very generic code and then just put a D in certain function calls and it will be distributed. And you can have Takafumi writing all your distributed code instead of having to do it yourself. So there's a lot of questions I'm seeing about comparing Python and Julia and how good is, I guess maybe separately, is how good is Julia for machine learning and stuff. So I would say, like, Python is a great language, and there's a reason that it's so popular, and that it's got a great ecosystem and it's easy to learn and stuff like that. But I would say that I think like okay, so there's some great advantages of Julia, just like, even discounting the ecosystems and stuff like that, just the language semantics. I think I kind of like Julia's semantics a lot, but let's say you don't care about that, you just care about, how do I use packages to do things, then it becomes kind of hard to make concrete recommendations without knowing more about your specific situation. So I think that it kind of just depends on what sort of user you are, if Julia is a great fit for you or not. Because basically, I think like a lot of the advantages of Julia and the biggest differences between Julia and Python help package developers a lot, and are not necessarily aimed at new users, but what this does is it lets people create packages that are very useful to new users, and it lowers the barrier to making those packages, and it makes the users of those packages more. It makes it easier for them to start contributing and be a part of the development of those packages if they want to. So if you're a very package-oriented programmer, so you are writing scripts where you're basically using a package the way it was meant to be used, like say you're a PyTorch, you're doing a lot of stuff with PyTorch or something like that, and you're doing very traditional machine learning and stuff like that, or any other, like, you use, I don't know, whatever, then it kind of just depends on if there's a Julia package that actually fits your needs very well or not. And I would say that most people find themselves, even if they're initially, using a package exactly how it was meant to be used, they're going to find themselves eventually in a situation where they have to do something that the package suddenly doesn't support very well. And then they have to figure out, okay, well, how do I get around this issue? Can I fix the package to do what I want to do, or is there, I know that there's this other package that does this thing that I want. Is there a way I can integrate that into my workflow? And that's where Julia really shines, I think, because it makes it very easy to, first of all, kind of roll up your sleeves and write, a fast loop or something yourself. But it also has greater composability between packages. So, if you want to write, if you want to use units like measurement units in your code, and you want to use rational numbers like fractions, and you want matrices of these fractions of unitful numbers, and you want to multiply them together, that's a very difficult thing to do in Python. And Python packages will not generally help you do that. And it's very difficult to kind of compose those things together, whereas it kind of just works in Julia. So for new users, it kind of just depends, is what I would say.
Just because we are starting to run out of time, we're about like 5 minutes from the end of this session. Maybe I would just recommend just like going through the list and seeing what questions you can answer with like one or two, like just very simple answers, so that we get more questions answered.
So there is a question about how efficiently Julia can handle big data. I think pretty well. For example, CSV .jl, the package to read the CSV file, I know that is very capable of reading very large CSV files. And also Julia has a built-in support for memory mapping files, so you can read file directly from the disk, and so you don't have to load the entire file on the memory, or you can read just some parts of the file when you need them. So you have a bunch of different options to deal with big data.
One person's asking if they started using Julia today, should they be using the LTS or the current release? LTS stands for long-term stable. And I would say, like, if you're just starting a new project, new user, use the latest release. The stable releases are really for companies and people who have like old code that they want to make sure that it's, still works. They just want to run it on the latest Julia, or they want to run it on an old version of Julia because that's what they developed it for, and it has bug fixes or whatever. So just use the latest Julia if you're a new user.
So a question about, can Julia be compiled into a binary executable? Not really, not right now at least, but there is some work to be able to like create an executable or a shared library that can be called from other languages. And I think that will be a very great way to increase the adoption of Julia. So people can develop using Julia, but then distribute small executables or shared libraries, but not right now.
If you don't care about the size of the executable, though, then packagecompiler.jl will do this for you already. But, yeah. Someone's asking if there's a compromise on speed if you're using PyCall. So PyCall lets you call Python code from Julia. Julia is not going to do anything to speed up your Python code. So if your Python code is slow, it's going to be slow. If it's fast, it's going to be fast. And I don't think we have anything for optimizing Python code from the Julia side. So there's one easy way you can do it, though, and that's rewrite it in Julia.
Does anyone has written like a Julia code and shared by Docker? Yeah, if the question is you can use Julia in Docker, yes, you can. There is also an official Julia image in Docker Hub. And yeah, I think that also some companies do use Docker to run Julia in production. So yeah, you can do it.
What does the web development landscape look like in Julia? I don't do web development, so I don't know too much about this, but I know there's some cool stuff. Like there's a web server, Genie.jl, Genie. So that's definitely worth checking out. I think the developer of that package has been really dedicated and for a long time and has been doing some really cool work. And then, if you're just hosting like a personal website, things like Franklin.jl are really good for making like static web pages. Yeah, so I think it's slowly happening, but this is a smaller sub-community in Julia than certain other niches.
A question about, can Julia be used for embedded programming? It's a question that we already touched before, but maybe not necessarily. It depends on the memory that you have. And also it depends if you want, for example, to do some real-time stuff analysis. So Julia is a garbage collector, kind of memory management, which usually doesn't work very well with real-time, but it also depends on the constraints that you have. If you can afford some delays, some time, it may not be a problem, the garbage collector in Julia. If you want a very strict, very hard real-time workflow, then I would say no.
Yeah, and then the other thing is just that Julia is kind of designed assuming that there's a fairly large amount of RAM available. The language is kind of pretty optimistic about allocating memory and keeping it around if there's a performance advantage to doing it. So that's not always a great fit for embedded programming. Someone's asking, if I understand correctly, Swift types are all defined in the standard library. Users can define new types and define operations on them, like plus, star, etc. What does Julia do fundamentally different from Swift? This is kind of a long question, so I'm going to give you a short one. Julia makes it easier to do these sorts of extensions for any function with your own types in any position. I think so. I don't know too much about Swift, but from what I understand, the way you do a similar thing in Julia is kind of more flexible and a bit easier. But generally speaking, if you have an appetite for it, you can add your own types to kind of lots of functions in Swift as well.
We are almost, we are at time, but I don't know if any of you have like one final question you really want to answer. We can do that and then wrap up.
Is the learning curve for Julia quicker than other languages? I would say yes. So if you want to learn Julia, go for it.
I will say yes too.
I think maybe I'll be a slight contrarian here and just say that I think that sometimes Julia expects a bit more of its users than other, like Python or something, where it will be less eager about it'll throw errors sometimes, where Python or R or MATLAB will kind of assume that they know what you meant and then just try and do something and produce some behavior that is maybe wrong. But this can be frustrating for some people. And also, certain optimizations don't happen in Julia automatically if we can't prove that it's always beneficial to do that, or that it's almost always beneficial to do that optimization. So sometimes you have to opt into certain things that are automatic in other languages. But I think there's a few things like this where the language expects a bit more of you, or asks a bit more of you, but it makes you a better programmer in general. And so maybe you're sacrificing a bit of time on the learning curve, but I promise you'll get a lot out of it. I think that's what I'd say.
I like that framing, Mason. It'll pay off eventually. And I think with that was a great question to end on. I think. I still see there are some questions that weren't answered. I think some of these questions actually were answered in the beginning. I don't know what was the timestamp on them when they were asked, but for instance, the Python versus Julia, that was kind of a dominant topic in this call for some reason. But anyway, it was discussed, and there's a lot of content about that specific topic online as well if you are interested to learn more. And if there are more specific questions that we didn't get to, again, the places to ask them are Discourse or Slack. And I don't know, maybe Mosè or Mason will be the ones who will answer them as well. So you never know. But yeah, with that, I just want to thank Mosè and Mason again for actually making the time and coming to this session and answering all of the questions. And thanks to everyone who was watching us and asking questions. And thanks to Logan, who is always setting all of this up and writing all the links and finding the links much faster than I can find them. So thanks, Logan. And yeah, with that, thank you, everyone. See you next time. I think the next one will be in May, early May. Yeah. Okay, thank you. Bye.
Thank you.
Bye-bye.
It was really fun.
Yeah. Thanks.